Okay, my friends, this is going to be this is going to be an explosion of every neuron in your brain because we have been told that everything sort of that just goes on and on and on. It's all normal. No, it's not. There is so much perturbations in the cycle of the Earth's path through the galaxy. It's unbelievable. Listen to this. This is Velikovsky, my biggest hero in the world. And he did the research of all the ancient texts. Now listen to this. This is an absolute mind blower. Get ready, because put a plastic bag around your brain because it's going to flow everywhere. Here goes.
Our planet rotates from west to east. Has it always done so? In this rotation from west to east, the sun is seen to rise in the east and set in the west. Was the east the primeval and only place of the sunrise? There is testimony from all parts of the world that the side which is now turned toward the evening once faced the morning. In the second book of his history...
All right, oh, you understand, it just means that as far as the people on the earth go, they see the earth going this way one day, and the next day going this way. What's going on with that? Now, what happened during that transition? What kind of an upheaval was there?
Herodotus relates his conversations with Egyptian priests on his visit to Egypt sometime during the second half of the 5th century before the present era. Concluding the history of their people, the priests told him that the period following their first king covered 341 generations, and Herodotus calculated that, 3 generations being equal to a century, the whole period was over 11,000 years. The priests asserted that within historical ages, and since Egypt became a kingdom, 4 times in this period, so they told me, the sun rose contrary to his wont. Twice he rose where he now sets, and twice he set where he now rises.
All right, so basically what they're talking about is the rotation of the Earth flipped. Now, could it still rotate the same way and have the sun be coming up from the wrong direction? How could that be possible? Well, I think I figured out a way it is possible.
This passage has been the subject of exhaustive commentaries, the authors of which tried to invent every possible explanation of the phenomenon, but failed to consider the meaning which was plainly stated by the priests of Egypt, and their efforts through the centuries have remained fruitless.
Well, mine, I think, is the only explanation that works, because there's a thing called the right-hand rule. You're not going to spin this way today and then spin that way tomorrow. It's just not going to happen. So how could they feel that the sun rose from the east and then rose from the west? How did that happen?
The famous chronologist of the 16th century, Joseph Scaliger, weighed the question whether the Sothis period, or time reckoning by years of 365 days, which, when compared with the Julian calendar, accumulated an error of a full year in 1,461 years, was hinted at by this passage in Herodotus, and remarked, "Sed hoc non fuerit occasum et orientem mutate." No reversal of sunrise and sunset takes place in a Sothis period. Did the words of the priests to Herodotus refer to the slow change in the direction of the terrestrial axis during a period of approximately 25,800 years, which is brought about by its spinning or by the slow movement of the equinoctial points of the terrestrial orbit, precession of the equinoxes? So thought Alexander von Humboldt of the famous passage of the second book of Herodotus, which so strained the sagacity of the commentators. But this also is a violation of the meaning of the words of the priests, for during the period of spinning, Orient and Occident do not exchange places. One may doubt the trustworthiness of the priests' statements, or of Egyptian tradition in general, or attack Herodotus for ignorance of the natural sciences.
All right. See, Herodotus had the same thing. Ignorance of the natural sciences. Well, there was a bunch of academics back then too. Well, let me show you what can happen to things moving through the atmosphere that are charged up. And guess what? The Earth is also a charged particle in space. Okay, this is going to be a shocker that you won't hardly believe. This is the magnetic North Pole location in 1840. Now, this is European Space Agency. I have a good friend that was with the European Space Agency, and NASA's too, actually. But look at how 1920 it was only here. 1980 was, look at this, like a rocket ship. Why? Why would that happen? I know why. Okay, you have to have a little bit of scientific background to understand this. But charged particles means you have a north pole and a south pole. That's all. It's just a charged particle means one side is positive, one side is negative. That's all. Well, what is the story with the Earth? We all know we have a north pole, we have a south pole. So what does that make Earth? A magnet. All right? Earth is basically a magnet. Now that magnet is spinning like that as it's in space. Now what's in space? It's supposed to be nothing? No, that's not true. There is magnetism in space. All right, because what are the magnetic particles? We know there's magnetism. You can see the aurora borealis and all that stuff, and we know that charged particles are hitting us, so there's charged particles in space, which is magnetic particles. If we push against them with our charged particles, because we are a charged entity, we push against these charges, they push back. All right, that creates push to shove, which creates the magnetic field. And this is what it is right here. There's a magnet around, literally a motor. And this is literally like the electrons that surround the Earth. So what happens? We have inside of here, we have the exact same thing. We have a magnet and we have a motor. Now, what are we looking at here? As a meter, and it's attached to this motor. And this motor is a DC motor, a direct current. So if I turn it one direction, we're going to get positive current. If I turn it in the other direction, we're going to get negative current. Watch. You see? That's a minus. We're in negative territory here. You see it? Now, if I turn it the other direction, we're in positive territory. See? And all I am is generating electricity. That's all the Earth is doing, is generating electricity. That's why you have a north and a south pole. And the electrons wrap out around and they come back into the bottom. That's why you see all the fields represented in these drawings like this. Yes. Now, what's happening though? The magnetic North Pole is shifting like a rocket ship. We are about to flip. And when we do, we got issues. Now, Velikovsky gets so deep in his research of every historical event, and he didn't just go to one source. He went all across the world, and if they didn't match up across the world, he just discounted it as being silly. And these were disparate people. In other words, these people over here had no idea what these people over here were doing. They had no context. So these people had the same story as them. It's correct. Now, what would happen when the pole charges up so much that it flips? I would suspect there'd be a terrible catastrophe where the waters and everything would override the land, and I mean the whole thing would be, because I honestly at this point I'm not sure whether the Earth would reverse its spin, and it might just stop spinning. I mean, there's stories of the Earth stood still and then it would start up spinning again. Obviously, if it stood still, it would have to start up spinning again. And I know it will start up spinning again very quickly, and it will get to exactly the right speed because it's push to shove. It's how fast it's rotating around our solar system, which is our star, our sun, and how hard it's pushing against whatever's in the atmosphere. And eventually it'll get to an exact speed, like 60 miles an hour, you stay at 60. You can slam on the brakes and go to 0, and then zip, right back up to 60. And I think that's what happened. Because it's got to spin to the right-hand rule. It has to going through the space. There's no other option. It's push to shove of the electrons. And let me show you in light, because this is nothing more, we are nothing more than a particle of light, basically. Literally just like exactly like a particle of light, a polar particle spinning through all other polar particles, which is the gases in the vacuum of space, which is not a vacuum, it's loaded with particles. And that's what we're spinning through, and that's what this whole system is about. And right now our system is so overloaded and so stressed out that we're scrubbing so hard now that the heat is just intense, the turmoil, the tornadoes, the hurricanes, the shifting weather patterns. Antarctica, I believe it was Antarctica, just warmed like absolutely amazing. I think it was like 30 degrees Celsius higher than it should be. Just like that. We're ready to go. And when that happens, yikes. That's all I can say. I'm going to show you this in our light experiments. It's identical. In 2017, the magnetic North Pole crossed the international date line, passing within 242 miles of geographic north. So it's basically right at the top of the North Pole, and now it's heading south. You see this, 1999, 2019. Watch these particles. You see these two magnetic fields? You see these two magnetic fields? Well, what's a magnetic field? A magnetic field is nothing more than radiance of energy. All right, so these were both pretty much equal, and now they're not equal. Now let me show you something in our light experiments. Okay, these are from our experiments. This is a red laser, but you can see the particle is spinning going forward, and it really is spinning. It is not a flappy wave. It's a spinning particle just like this. All right, I showed you from the side how they're spinning. This is looking straight into the spin. Okay, this is when we filmed the red laser coming in. Now this is one shot taking the same particle. You can see the white is in the back, you see the white is in the front. That's a polar shift. That is upspin and downspin, they would call it, from Fermilab or somewhere. And this is where they actually split and divided. Now, we don't divide, but we're going to split, I believe. And when we do, I think it flips just like that. And I'm going to show you the green. Green and red, all photons are the same, but green is very powerful. And you can actually see the actual where it turned. I'll show you. All right, now, check this out. This is the green, really, this is really powerful. Now, here it is, overcharged somewhere here. Whether it's going to go push this way, you know, because it's going through the air that way. And it's being charged up here more because well, I'll show you the actual photon in the red, and you can see the difference in charges. However, we know this is going to be overcharged. Will it flip this way and let the white come up in front at the top and have the white at the bottom? And the black now will be in front of the white, so this will start to discharge. And that one will start to charge, so it's this way and this way and this way and this way. I believe that's the case now. What would that do to us on Earth? All right, I showed you the light particles coming through and doing this flip-flop. Well, we may be just this type of a particle, which has the magnetic north. It's just a bar magnet, basically. And because we are spinning this direction, all right, this is turning this way. This is the way the Earth turns. You see this in North America and so forth. So we turn this way. This one here is concussing hard. Boom. It's glowing, just like the white particle I showed you that glowed. This one is trailing. This is hanging off the back. Now, at some point, this will overcharge so much, because it spins every day, that it will flip the poles. Now, I'm not sure what's going to happen when it flips the poles, but we can see the pole is shifting from the potential energies. The energy is draining from here over to here. You see it? And it's because of how the impact was. Originally it was, we're sort of drifting through the atmosphere, which is just barely outside here, and we're just sort of working our way, and there's no big tornadoes and hurricanes too much. And then after Industrial Revolution, and we filled up our gases, now we're way out here. And it's scrubbing. Well, what's scrubbing? This. Well, actually it's scrubbing this way. This is the way the Earth turns. All right, so it's, and that one there is puffing up like a balloon because it's hitting all of the particles out here. I'll show you another representation of that. All right, we can see this. We know this is a fact that everything spins and all the particles spin. It's the right-hand rule. And I'm deep into physics and so forth. I understand this stuff pretty well. And I know there's a lot of people that are all upset about space and so forth. Please don't do that here. This is my research, and if you don't like this kind of stuff, well, then probably it's not the best place for you. Anyway, everything spins this way, and you can see the separations of the particles, and that's because it's push to shove, push to shove. As these glow, they're pushing against these, and everywhere in between there's dark, 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 dark. And I show that in all my light experiments. Now, it's being wrapped back because this is spinning, and there's a whole batch of particles everywhere. So it's pushing those arms back. And when they push back, they create push to shove, push to shove, push to shove. And then by the time it's wrenched down in here, just like a wrench, you turn your hand out here, you can do this. But right down here, it's like, it's really just, you can't do that with your fingers down here. You can do it with your fingers out here. And that's what's being pushed against it. You got to think really like a simpleton. I think very simple. That's why I'm simple-minded. I don't care. But when you're simple-minded, you see the things that everybody, oh, no, we got to have this and that. You can complicate things so complicated, they just make no sense at all. And that's what's happened. All right, so imagine this. We're ripping our way through the arm of the Milky Way. And everybody's spinning around the sun, and we're all spinning the same direction. We're not going to turn the direction, go backwards around the sun. We are going to spin around the sun this way. Now, we may not spin on our axis in the same direction. That is to be determined. But if the sun rose in the east and then it rose in the west, that's got to be some kind of a flip. And I think that's going to be that muon wobble that we saw in light, and because we're nothing more than the same thing. We're getting charged. We have a North Pole and a South Pole. It's exactly the same thing. It's just a little bit bigger. All right, I talked about the North and the South Pole of our planet and the sun. This is the moon shading the sun. This is the poles of the sun. It's spinning as well. And remember I told you that it's nothing more than a motor spinning in space. And what is it spinning through? It's spinning through magnetic particles. It's just like this would create. Magnetic particles here, and here's the sun. It's spinning through these magnetic particles. This is the place where it pushes here and here. The poles, you don't see, that's where the transfer of energy is going. And it's all to do with these particles. Tons of them out here, so we're scrubbing through those. Remember, see these real hot spots here? This is the spin. You can tell because the intensity is on this side. The trailing edge is on this side. You don't see that over there. So it's spinning this way, really scrubbing hard. And this way it's just streaming off. Now, this makes it extremely crystal clear. We're spinning this direction. What happens as we impact everything that's coming at us, which is basically sunlight is the primary, really heavy, dense source of what's coming at us. The intensity here is astronomical. What happens? We transfer all of those particles into our atmosphere because they're pushing and we're shoving back, but they're settling in. They're not just floating off into space. Some of them do, yes, but most of them stay on Earth. A lot of them radiate down, and we have a layer here of heat, which is 2,700 degrees, and our Earth is, let's say, 100. Why is it 2,700 out here? It's because of this scrub zone, and it's not just here. This is the intense scrub zone. This is why all day long you say heat of the sun and all that business is, on the equator where it's really facing right at it every single time. Now, but the scrub is always loading this, which is heat. There's nothing more than heat. Heat makes everything swell. Our atmosphere is swelling like unbelievable. And as it swells, we get more and more turbulence and hurricanes and tornadoes and floods, climate change, global warming, crops, desertification. All of that stuff is happening. And it's not going to stop because we're just keep expanding. They know this. But it's industrialization, and it's the burning of all these things, cars and airplanes, and everything that burns something, anything that expands gases, and even microwaves. And 5G, I think, may also be contributing to this. I'm just an honest scientist, and I'm telling you what's happening. We got issues, and if we can't move this down, we're screwed. All right, I'm going to leave it at this. I showed you we had the black and white balls attached together, which were the photons, and one of them was the black ball muon, one of them was the white ball electron, or neutrino, and here they are separating. That's fission, that's fusion. This is supposed to create 200 times more energy than when we first started. I say it's a possibility, and it's just a possibility, but it could be done within a couple of weeks if it works. All we have to do is take lasers, which are a dime a dozen, put them through a Venturi, which just has to be engineered exactly the size to only let the white through. And that's what happened. You saw the white was a fluffy, crushy part. That gets through. The black doesn't crush, it doesn't compress, it doesn't do anything. It's only gravity. So it breaks away and comes back over here. This is raw energy. I believe we can harvest that and get free energy. That's the only possible way that we can reduce the gases that are now expanding like crazy. And that's the reason it's 2,700 degrees out here. They never even account for that. And they have no idea why it's so hot out there. They have no idea why it's so hot out here either. It's millions of degrees outside the sun. On the surface, it's 10,000. No explanation whatsoever. The only explanation is we are rubbing through all these particles that are in space that they have never even thought about. We got a lot of issues here to deal with in physics and to save our planet, my friends. So I need help. All I had is dismissive people. I haven't had anybody help at all. Not a single person that has oh yeah, we got to do this. Well, nobody in government, nobody in universities, nobody in any field of science will even consider this. I've been thrown off to this boat by Fermilab. I hate to keep going down this road, but we're going to end up done. Now you saw the early times, it was just barely changing, just barely heating. All of a sudden the Industrial Revolution came, and the expansion gases are the things that are going to flip us. And it's flipping fast. It's flipping fast. And if we don't do something about this flipping situation, we are going to flip. And that is not going to be a pleasant situation.